To connect two resistors in series, pull down two resistors, a voltage source, and some wire. You can change the values of the resistors. You should try to use two different values for each of them. You can also change the voltage of the power source from 0 all the way up to 120 volts. This should give you plenty of range for voltage. To measure the current passing through the circuit, connect an ammeter in series with all the elements of the circuit. You can see that as the voltage is changed, then the amount of current measured by the ammeter changes. Once your circuit is complete, choose 10 different voltage values over the possible range of voltage for the power source, and for each voltage you pick, record a corresponding current. Make sure to record the resistance of each of your resistors in the circuit. I have chosen the same resistors for illustration purposes. Yours should have different values. Once you have completed the table, then move on to the parallel resistors. To complete Table 3, first construct your parallel circuit. To make your two resistors parallel, line one up underneath the other. You will need some extra wire to complete the circuit. The ammeter can be connected between one end of the power supply and your pair of resistors. It will then record the total current passing through the circuit. Your current will actually split itself up between the two, then join up again before moving toward the power source. Change the voltage on the power source as you did for the series circuit. You can use the same voltages that you used in that part, or you can choose 10 new voltage values. It's completely up to you. Once you have filled in the table with voltages and corresponding currents, you're done. As far as the analysis is concerned, you're going to take the data from your 5 data table sets and plot graphs of that data. You will pull them into Excel. You will want to list your current in the first column and voltage in the second column so that current, which needs to be in amps, will be plotted along the horizontal axis and voltage along the vertical axis. If you do this, then according to Ohm's law, voltage is equal to resistance times current. The slope should be the resistance of the circuit. For the individual resistors, the slope should be equivalent to the resistance of the resistors that you chose for each run. For the series circuit and parallel circuit, the slope should be the equivalent resistance of those two sets of resistors in series and parallel, respectively. The equations for each of these equivalent resistances can be found in the textbook. What needs to be turned in? The completed lab write-up should include the 5 graphs that are asked for. They should be stretched to fill a page in your Word document and fitted lines extended to the y-intercept. The equation Excel used to fit the data should appear on the graphs along with proper labels on the axes and proper title for each graph. There are calculations that need to be completed, such as finding the equivalent resistances for the series and parallel circuit and the percent differences between all resistances for the circuits compared to the resistances from the slope. For the series and parallel circuits, this comparison would be between what you calculate the equivalent resistance should have been and what the slope of those graphs say it is. Finally, there are the data tables and the answered questions.